Hello. So this is the second part of the workshop. In the first part, we went through some of the basics of multiple development, and we looked at a couple of scenarios, such as reverse engineering or browsing an API. And then we looked at how we do domain discovery. So kind of some sort of an executable or visualizable domain-driven design. And the reason we did that was to show that we could do everything in the same environment using the same approach, the same way of thinking, same tools, same techniques. And by doing that, we kind of validate this idea that multiple development is a systematic approach that you can learn once and then use many times over in many different kinds of scenarios. So, but this session, I think, would be interesting to start with you now. So a couple different questions could be, how do you, where do you see this one applicable, and other thoughts that you might have so far?
Well, I wrote down like one question. So, well, in the beginning of your talk, I was seeing like, hey, how does this differ from like live books or Jupyter kind of tools, where hey, you're also currently inspecting everything, and another kind of system I was comparing it with was like in Aardling and Elixir, you also have, I don't know how the tool is called, but you also have a runtime view on the full system. And so I was wondering a bit about that, but with your second demo especially, I did see the difference going. But then what I was wondering is like, okay, you want to make the cost of writing these tools as small as possible. But one thing I could see is that as soon as you start refactoring your base code, you need to refactor these tools as well, of course. It's the same thing with tests. And I was wondering, like, are you going to, what is the experience with that kind of thing? Like when you do bigger refactorings or well, depending on how you define refactoring, of course, like maybe think about bigger changes. Does it have a big impact on the tools you've written so far, and how much overhead does that add there?
That's a nice question. I'll say differently. So the tools that you have seen, the views that you have seen, they are a tiny fraction of the tools that we create. So the economics of tools is, until now, or classically, is such that people want to build a tool and then reuse it multiple times so that the investment amortizes itself, right? But when the cost of the tool is small enough that you can amortize it on the first use, you don't care about reuse. Reuse is a nice thing to have because you get multiple returns afterwards, but it's not mandatory. So you shouldn't worry so much about those tools. It's a totally different frame of mind. And again, like the comparison with other tools, it's absolutely warranted. And the other interesting thing about it is that, of course, so the goal of this kind of workshop is to talk about multiple development as a discipline. But of course, we can't practice multiple development without an environment. So we created an environment the way we think it could look like. And when people look at this kind of environment, they would see similarities to others. Notebooks are some static analysis, others language workbench, others visualization tools, another one, a knowledge management tool, somebody else would see. So they would see different kinds of parallels, and they would be kind of, but the interesting thing is not in the similarity, because this is a new class of an environment. So, and that it should be judged by the kinds of things that it enables, not by the features that it apparently has. And so that's a bit. So, but ideally, we should be able to talk about multiple development in abstract, but we noticed that it never works in practice. And so this is why we are showing it to you in a very concrete environment. But once this one flies, I would expect many different flavors of environments to appear. My single worry is that I would like people to copy the depth and not keep it on the shallow things.
But so I definitely understand what you're saying. Like, hey, ideally we should discuss abstract, well, about moldable development and not necessarily the tools, but well, the reason you're building something is to show that it's possible to make something like this economically, because I think that would be like, for me as well, but maybe I should think about this some more, or maybe you have some nice examples. It's still hard to think about let's say we're developing something and now, oh, I need this tool, and I can quickly create that tool, that it's usable and that it's adding value for the first time of use, because creating these kinds of tools so far, it's quite expensive.
Yeah.
And so
Well,
I'm wondering, yeah, that is, you're confident that you can solve that?
no, I'm confident that we are practicing it since almost a decade. So, I mean, we're running a business also, so which the fact that we exist is already a validation. So all our projects, we work with two kinds of projects. On the one hand, we work with people that are some sort of a crisis, typically about a legacy system. And in those kinds of projects, we have to compete with people that work there for years, sometimes decades. And within weeks, we have to tell them something that is novel and of value. And so that's a disproportionately unfavorable situation, right? So we shouldn't be able to compete with them. Ideally, like if engineering would be a commodity, and if we would understand it thoroughly, like you shouldn't be able to have 2x and even less 10x kind of difference in specific kinds of activities, right? That should not be possible. And the fact that we are able to do that shows that we don't have a good understanding as a field of what does it mean to construct or to work with software systems. So this is one kind of, I mean, ideally, the validation for what we're doing would be some sort of A/B tests, right? Where you would have somebody creating with or without, but those are expensive. And the other thing about it is that you would need to do it at for a real life things, like tiny experiments don't work here. It needs to be it need to be things that add value, that have ideally business value. So creating A/B tests at that level can be difficult. So instead, we are validating it, or at least providing empirical evidence by, as I saying, like doing kind of disproportionately unfavorable scenarios. So the other kind of projects we work with are companies that are seeking a competitive advantage. So, for example, in the second part, I was showing a domain, like it was this domain discovery situation. There we were competing with people that were drawing on the whiteboard. So, right, so like if you can keep up with the implementation at the kind of the same speed and have it as explainable as people drawing on the whiteboard, you do open up a whole new way of having conversations. And then imagine literally having investor pitches given in the development environment, like a demo like what you have seen. Show that one to an investor to describe what something interesting is about, for example, an algorithm or so. So this one unlocks a kind of business value that is, like nobody taps onto it, right? If at all, people are showing PowerPoints. So again, like how we think that this can generate a dramatic new kind of value. We also think that we're at the very early stage of exploiting this, because this is like a new feedback loop from my perspective. It's like with tests, right? We used to have 20 years ago, we used to have similar, right? You would have a department that would do testing, right? And they would say, yeah, but automation, what could this bring? I mean, we already have all these tests that we're doing. So if you would measure the first test, right? If you have your 20 testers that are doing testing, and then you compare what they do with the first test that you put in place, it would be like a disaster economically, right? First of all, is because to set up the test, there would be a humongous effort there for that first step, because that legacy system was never made to be instantiated outside of a certain thing. So it would be a complete disaster if you would compare it like that, right? Now, in the meantime, we know that it's actually not true, right? So the way you evaluate value in these kinds of situations, especially when you have a new feedback loop, is you look at the compounding effects. You never compare it with the immediate first things. Because if you're comparing with the first things, then it will never come true. But in our situation, like for example, with the API thing, you can literally, with a very small investment, you can throw away the other API tools that you're probably using, because it's just going to be much better and much more flexible. And it's a very simple use case. It's one of those really simple use cases that you can just apply like this. Now, so maybe one of the things that we could go through today would be to see how do we use these kinds of views for actually driving our own work, because the environment itself that we're creating, we're doing it by following the same approach. And so we ourselves, we are also competing with others, but we have a small team, and we with this small team, we not only do we do case studies and the methodology, but we actually built a whole new graphical stack. Like all the widgets that you see there are created completely from scratch on a new graphical stack that has new properties. There's a language workbench, there is a visualization engine, and so on. So there are lots and lots of things there that theoretically shouldn't be possible to build with a small team like this. So again, I'm not saying that this one is an absolute validation, but it potentially is an empirical evidence.
I can easily imagine how if you come into an organization with your 10 years of experience doing this, that you can beat the odds. But if a team is completely new to this,
absolutely,
and maybe without your help, at what point does this become sort of viable, right?
Right.
And I get your testing story, right? That's a perfect example of sort of an investment that has massive second order effects and everything. So that makes sense. But what's the learning costs here?
Right. So remember when we said that with moldable development, you have these two roles. You have facilitators and you have stakeholders. The stakeholder is the one that owns the problem, and the facilitator and knows how to make a decision, and the facilitator is the one that knows how to create the tool and project the problem onto some sort of concrete data. The way we typically start, right, you always start from a very concrete problem, and ideally a problem that has business value. So that has a recognized business value, not that it has business value, but has visibility of the business on the business side. And the reason this is like this is that we saw that if we project economic value, we have a much better chance of actually creating retention within the company, for example, after we leave, in our case. But this is what we kind of suggest people start with, something that has value, at least for you, but ideally, if you want to introduce it in a team, start with something that the business recognizes as a value. For those kinds of things, so for example, it can be, let's say, if you take a legacy system, you want to do some sort of a migration. What migrations boil down to is saying, find me all the old places, all the old ways of doing things that I don't want anymore, and then ensure I don't have them anymore. But that's pretty much it. What a migration is. So if you find all of those places, you've already solved a good deal of your problem. This is a very nice case to start from. And for this one, the typical ramp up of a facilitator is somewhere around 5 days to learn how to learn, for example, with the environment. And it takes about 1 person month to get proficient at exploring or expressing architectural constraints, for example, and basic visualizations that are good enough for providing value. So this is a ramp up on the facilitator side. But the most difficult by far is not the facilitator. Because in a team of 10 people, you will always find one that loves to work with some tweak something, some tool, there's almost always going to be a toolsmith in that team of 10 people. But the most difficult thing to change is the stakeholder. Now, why is that the case? Because, so let's take a look at, I'm going to share the screen. Let's take a look at how the flow of moldable development looks like. So we have this, right? So in this situation, we have we start with the hypothesis, and then we apply an analysis and interpret, and we're confident, and then we do something. The thing here is that the most difficult thing is not this. The most difficult thing is asking the question. So you can do this experiment with developers. We do this all the time. That's how we warm up on the facilitator. Is sit with the developer, ask, so what is the task about the current thing that they are looking at? It can be a bug, it can be an issue, a new feature, or whatever. It doesn't matter what it is. And then ask, why do they look at the screen they're looking at? That's it. That's the question. Why this screen? So why is this an interesting question? Well, think of it like this. If you don't know, so you can have, let's say if you have 1 million lines of code. So, and a screen will show you 50 lines at a time, right? So we have, what is it? About 20,000 screens, right? Possible. So if you don't know why you're looking at the current one, you have 1 in 20,000 chances to look at the right screen, right? So it's like using a random approach for that is just not a good thing. Now it turns out it is not completely random, but people they rely a lot on pattern matching, and that pattern matching is not a conscious decision. And the most difficult thing is to bring that impulse, bring it into consciousness and say, why do I look at this one? So treat every single investigation as a little scientific method exercise. This is by far the most difficult thing, by far. Like, it dwarfs everything else. So the facilitator is easy. You're always going to find somebody that does this. The most difficult thing is this one. The way we deal with that is by introducing process in this space. So it's something that we call a daily assessment. So, for example, when you're having a daily stand-up, right? Very often people talk about what they did, what they want to do. There's almost never a decision that is being made at that one. So it's a synchronization meeting. That's the first thing. But the second thing is, nevertheless, even that one, when if you look at the compound of different kinds of interactions that people have nowadays in a more, let's say, agile setup, you'll see that there's some sort of planning, some sort of negotiations between technical and non-technical people, maybe some sort of review, which is another step in the negotiation, and maybe something in between to see progress. But a lot of it is simply about orchestrating the negotiation between the different perspectives, so like the technical and the non-technical perspective. And that alone did a lot of good, right? It created a feedback loop that didn't exist before. And just having that one in motion and just going through meaningful feedback, that's another question, but let's suppose that those kinds of meetings actually generate meaningful feedback. This gets you in a completely different place, right? Because you get to negotiate what is going to happen, maybe based on reality, ideally, you know, even if you take into account what happens in DevOps, that's kind of what happens, right? So you now have the possibility of actually experimenting things in real time, and then the business can react left or right, depending on what things, depending on real life or live data. So, but if you think about it, when do people negotiate architecture? Right? There's no there's no real place. There's no systematic way in which people negotiate architecture. Really, there's no place where people say, "Oh, how do we debate? What's a structured way to find an interesting new compromise, or discover when we're actually going the wrong direction, we should go somewhere else." So code reviews is a way to do that, but it's very narrow in scope. Like, it's very focused. It's like having a magnifier glass all the time. So that doesn't it doesn't quite cut it. So we said, well, we have this process which is called daily assessment, which is we start with the hypothesis. I don't have it here. Do I have it here? I don't. We start with a rule. So let's say a stakeholder starts with looks at something, sees something wrong in the system, and then says, okay, now I have to go and talk with the facilitator. Those are two different roles, ideally by different people. So we're going to talk with the facilitator to create a tool that I can then use. And once I have a tool, there is a meeting in which you can only talk if you have data. So you cannot talk if there's no data, nobody talks. And this is a meeting which is a kind of like a stand-up. So it's supposed to last. It should be very short, but it's targeted specifically for decision making. What we found is that if you take a group of people, put them in a room and start talking about architecture, you can come up 3 hours later, and it's highly entertaining. It's one of the most interesting team building exercises you can make, but there's no decision at the end. But at the same time, if you take the same 10 people and you show them very concrete examples, we think this should be like this. These 10 places over here should be changed in this way. You will find that people find the resolution within minutes. In fact, we noticed that if the conversation takes more than 5 minutes, it means that the data is not good enough or it's not presented well enough. So it turns out that in a situation like that, it's enough to start with some examples. I'll explain maybe a few of them. And then just have this, it's like a treadmill. You start the treadmill and give it something to crunch. It doesn't really matter what you're giving it to crunch, because the first goal is to just build up the muscle, basically. Build up the muscle of saying, here's the question, here's how we look at it, here are the actions that we can make. So at the end of the meeting, people want to make a decision whether or not they accept the new rule, and if they accept the new rule, whether or not they accept the direction. And once they accept the direction, you transform those into immediate things to do, and ideally split those into little pieces that do not disturb the velocity or the normal flow of work. And there's the reason for this is because you want to introduce this new ability without having to ask for budget, without having to disturb everybody else. So if you can infuse a new technique by just in a piecemeal fashion is have a much better chances of actually it sticking and much less friction. But what also happens is that as a result of this process, basically, if I see something that I want, if I see how a system, if I see something and I want the system to change, and then my teammates are gonna perform the changes, all of a sudden it means that the team works for me. So at first, few people, well, very few people, one or two. Again, like in a team of 10, you usually have one that is more vociferous, but like they want to say something. They don't necessarily have to be the one that say the best things, but there's one or two that are louder than the other ones. So they are typically the ones that will volunteer, that will want to impose basically, or to set the certain directions for the team. And but once what happens here is that this is a positive feedback loop, or at least this is how I see it, is that basically people, the other ones see, oh, look, I'm doing what they want. So it means it's in my interest to actually say something, because they will then, because if I say something, they will do what I want. And so it basically, it just reinforces it. Once you see 2, 3, 4, 10 of these kinds of going through the treadmill, then says, oh, I want it, I want to try as well. And then you can piecemeal just add your perspective, transform that into a tool that shows a view, and then give that to the team to make a decision. The team makes a decision, they make the change, and then just continue like this. So once you have something like this, in our experience, it takes about 3 months to incorporate as a feedback loop. And then after 3 months, it has a chance of being sustainable.
Could you give a concrete example of like, not of the whole process, but of like some, maybe a discussion that you had with a client, if you can share something? Okay. Like, hey, we had this kind of problem and we decided to build this kind of tool. Like something not trivial, of course, preferably. Yeah.
Right. So actually, this is not the problem with these kinds of projects is that when they are not trivial, you're not allowed to talk about them.
Yeah.
To publicly. But we actually we had a chance to participate in a hackathon where we had access to a team that would describe to us concrete problems. So, and these problems were about it was about a system called OpenEDX, which is a reasonably large system used in online education. It's basically a platform on top of which you can create or host your own courses or things of that nature. And here they had a specific hackathon that which was focused on improving documentation. And one of the things that they wanted to look at were feature toggles. So why the feature toggle? So this is like a system that if you look at them, like this is we saw how many feature toggles do you have? And then they say, well, we have a few, and then we map them. So here's a visualization of the different places that are making use of feature toggles, right? And then you'll say, okay, so you have a reasonable amount of them. But then they said, let's document something. Let's like if you want, you can take a feature toggle and document. So these feature toggles, you can see many of them, right? These are the ways in which they can configure things. They probably also end up modifying what people pay for, right? So it's a significant utility that has also it's already exposed to the business side of it, but it's highly technical, right? In nature, right? It's just it's a tool that we often use in an architectural tool. So it turns out that here, not only one of the problems they were having is, well, we have three different ways of expressing feature toggles, right? So, and then one of the issues was, well, we want to migrate from the legacy one, at least, or the oldest one, to the newer ones. So in this situation, the simplest thing to say would be, well, which are all the legacy ones? Which are all the legacy toggles? So we built, this was the first thing that we built, and says, well, here they are, like this. We have these 28 of them. And if you look at them over here, we have that, and we can see where they are in the, it's even called in this case, a legacy waffle switch. Right, so these are the places in the system that should be migrated. The interesting thing is that if you have this 28, so when you say, well, you know, how long does it take to migrate away from the legacy? It's hard to say, right? It's because it could be that it's, you know, 1 week, or it could be that it's 1 year. I don't know. But now if I have 28 of them and I can go through them and says, well, what do I need to do here to migrate them? Then it's probably going to be a similar, right? So like if you figure out one of them, I can kind of figure out what the cost of 28 is with a reasonable, within a reasonable error range. So the only difference between the two questions, the question is the same, but I can yield very different kinds of results just because now I have an idea of the impact of it. And so this little thing, just having this list of 28 completely changes the equation by which we're going to reason about it. Now, the next thing they said, well, we don't have, so some of these toggles, we want all of these toggles to be described, to have a documentation, because this is what, you know, people are relying on it from different angles, both on the technical side, but also on the business side. So, so here, this is another query. So then it means, oh, can we find all the annotation, all the feature toggles that are not annotated? So we have 69 of them. And if you look at this, in this complete source over here, I should be able to see somewhere that it doesn't have a comment. And so normally it should be like this, but this one doesn't. So again, is this complicated? It's not complicated, right? Well, actually, it doesn't appear complicated. Because the thing is that this is just, you know, if you look at it, it's just some key value here. So it's like, does it mean that all key values in the systems have the same meaning? No, it doesn't mean that. Which means that now I need to actually, like if I look at this, I have to understand the framework, because the feature toggles here, they are based on the framework. So depending on which framework I'm going to use, I'm going to have different patterns being appear in the code, which means that this tool that I'm talking about cannot be built before I know the framework. And that's the key. This is the default situation. The default situation is not the one where I can predict the problems that people have. The default situation is that really interesting questions are unpredictable in detail. And that's the reason why it's impossible to create tools upfront. You have to start from the context and then create the tool. There's no other way around it. AI could help in the future by synthesizing possibilities, for example, but you will still have to understand and define what context is interesting, and then produce the tool. That's the difference. There's a very large difference here between those. So, and then the other thing here was, well, okay, so we can see this one, like these are the feature toggles that are not documented. But we can equally say, well, what happens when a feature toggle has the wrong documentation? So for example, here, there actually is a feature toggle, or there was at the time. Here I cannot. Yeah, so this is a feature toggle that for which the name that appears in the documentation. You see here, enable change user password admin, and here is enable password reset failure. So the documentation describes, like, this documentation is actually wrong. And again, like, this is one of those situations in which this is hard to see. This is like literally, this one has business value. There's like, everybody is incentivized to fix the problem. It is not because, right? It is not because nobody cares that this thing exists yet. It's just because whenever you rely on some, some convention, and that convention is not ensured or not checked by through some sort of automatic means, it's just a wish, and the wish might come true or not. You never know. So that's the problem. And again, what I like about this case is we were lucky enough to find one that is publicly available, and we can show it like this. But what I like about it is that literally, like, this is the cost of the tool. So here it was just a couple of days of exercise, and we started by not knowing anything about the system. So we didn't know, we didn't even have too good of a Python support here. So we even had to ramp that one up. So going from nothing to providing details about the system that the original team maybe doesn't know about or is not as aware of it. This is one of those kinds of examples. But then we can go further. So for example, here, if you think about one of the issues in this one that we know about is that they want to probably split the system. So when you want to split the system, you are always thinking about dependencies, right? And we hear about loose coupling, all of those things. Bounded contexts. And so, but the question is, which dependencies? Now, if I think about a feature toggle is defined, if I define a feature toggle here, but I use it there, it means that there's a dependency between them, even though I don't see it. I mean, it's just, in this case, right, this feature toggle that we're looking at here is a string. So like, you can have many strings in your system, right? Not all strings will generate a significant kind of dependency. But if you understand what that pattern is, then you can start building something like this. So let's imagine that these are bounded contexts that we care about. So now all of a sudden I can see here how the different parts depend on each other, but these are dependencies induced only by feature toggles. Right, so, and then if I click on, for example, one of these, I can see, where it is being used here. So which feature toggle are we talking about? And yeah, so this is, again, like, these are the kinds of things that we could possibly play with and do. And so this is an example. And what I like about the example, this one, is that you have to know, like, in order to reason about any of these, you have to understand first the semantics of the concrete frameworks that you're using, and those frameworks exist only within the context of the system, so people cannot even pretend that they have an out-of-the-box tools, right? So for other kinds of things, people can pretend. But then let's take a step further here. So one of the things we saw is, for example, we were playing with the React Native application, and just within a few weeks into development, we noticed that we had these cyclic dependency problems between components. And those are like painful kinds of problems to get, because you can only detect them, or you can only reason about them at runtime, and it's very, very late when this happens, and you don't really know what exactly happened there. And especially if I have a component that depends on another component that depends on another one, and then embeds this one back here, so have a longer path in the cyclic, it's kind of hard to figure out which one do you, like, how do you take this out? So we got into this problem soon, and then we said, well, what's the problem? Like, I'm sure that there needs to be tools for this, and apparently maybe we didn't look in the right place, but so we didn't find them, which means that, what do you do when I don't have a tool? I'm going to build one, right? Because That's the whole thing. So, so here I actually built a model out of the JavaScript code, but then on top of it, we have created these entities which are called React components. So I can look at one of these and I can see, for example, here, drawing header is la la la, and then it returns this kind of views inside, right? So I can see how they are being put together, these components. Now, if I can do so, for example, here I can see the checkbox depends on checkbox field. So, and again, like this is a very specific pattern. This is not JavaScript that you're looking at. Like if you're looking at the React code and you're just reading JavaScript, you're missing the whole point. So it's just, you know, the JavaScript part of React is just you know, incidental around there to the most part, right? Because you need to understand what how they define, for example, the graph of components, what the life cycle of components are, and so on. So, but a different view over this. So here I have a list of components, right? But a different view is something like this. So here I can see, for example, something like render button here, which depends on button. So that's why I'm going to have here a connection between render button and button. So then we built a little tool, and then we could immediately see what parts, how do we want to break our cycles when we got those. So this is one of those kinds of things. So not all cycles. The other thing, one of the interesting things about this problem is that when we ask people, you know, tell me what you want to know about your system, one of the first things people say is that they want to find cyclic dependencies. But the question is, which cyclic dependencies? Because again, like if I'm just looking at cyclic dependencies at JavaScript level, they can be interesting, but in this case, they're totally not interesting. In the OpenEDX case with the feature toggles they were also not necessarily interesting if just looking at the dependencies that I can see directly in the code. Here's another kind of here's another type of dependencies that you otherwise don't see. Maybe a final example. This is a Ruby system. It's a Ruby on Rails system. So in here, one of the things you have is you have something called application record or active records. And if I look at this in this system here, this is the superclass, and I look at the hierarchy here, I can see that this one, like there are multiple of these components and they directly map onto the database with this magic reflection that the Rails framework already offers. So if I click on one of these, this is going to be an actual class. I can take a look at the source code. Here, this is the source code of the class. I can see that this is addition. It's just a subclass of application record. And the other thing about it is that this one actually maps onto a table. So if I look into, there's maybe an SQL definition. So here, when I look at this class, I can see, oh, look at that. There's an actual corresponding create table additions. So notice that fact that this is small caps and there's an extra S. And then all of these attributes that I see here will actually magically appear as being attributes of this Ruby class, even though they do not appear in the source code here. So they can be accessed and played with directly here. So if I want to see the attributes of this whole Ruby class, I can see something like this, right? So here I see all of these role dash appointment, speech dash type, underscore. These are actually coming from the database. They are not coming from Ruby. Now here's the interesting thing, because when we think about Ruby, we think, well, Ruby is a dynamic language, which of course it is. But in this case, these attributes, they are not, you know, dynamically typed. They are very hard-coded type, because this document here will be of this type, and this rule appointment will be of this one, because that's what the schema says, right? So the schema is not not dynamically typed, And because we inject all of these ones there, then all of a sudden it means that there's going to be, we can leverage this information that we already have. And it's, again, like if I look at Ruby only, at the Ruby semantics, I'm not going to see this. If I look at the Rails semantics, then all of a sudden I am able to see it. And so once I can do something like this, then I can also imagine a dependency like that, right? So I can see that addition is actually made out of all of these other active records, or rely on all of these other active records, basically. So again, like this is another case in which we've constructed in order to reason and navigate through a Ruby on Rails system, we built a model and mapped it onto the navigation and a few views that would allow us to answer our questions faster. So this is basically the process that we go through literally every single project we see, all of them. And it doesn't matter. Sometimes we look at source code like this. Sometimes we look at source codes written in multiple languages that you need to correlate. For example, let's say you have on a client side something, and that this, like JavaScript maybe, and then the JavaScript calls some sort of API, and then the server, which is maybe, I don't know, Java, defines that API, and now you want to see, let's say you want to split the client side's code, and maybe you've already done some splitting on the server side, and you want the client side to match the splitting on the server side. So understanding and reasoning about the API calls, it's kind of an important thing. So you want to see, oh, where are the JavaScript components? What kind of things do they call on the API side? And again, like that one is just understanding that library, and then you map that one to a tool, and then you start reasoning about that. That's pretty much the process. Let's just address the question.
Yeah, I like somewhat. I'm not like, I probably need to experience it to fully understand it, but not like. But what I was thinking during what you're saying is like, hey, do you want to build a mindset around moldable development and just like don't care about the tools that much? Because, well, some of these things, like for definitely your well, one of the, I can't remember the example you gave exactly, but like sometimes during development, I've also built tools to be able to answer questions, like where tests were not enough, or you want to know something, you have a problem, you don't have enough data to answer the question, so you build a tool for it. So is that the kind of mindset you want to reach with moldable development, or is it that plus the tools?
There's no way to do moldable development without the tools. It's like saying, oh, I've done testing because I wrote 5 tests. So that's not testing, right? So if you want to leverage feedback loop, you leverage feedback loop and you invest in it. That's from that perspective. My argument is that the reason people, so I showed you at least 3 or 4 classes of problems, and not once did we rely on reading. So I could explain things to you about real life situations. Like these are, none of them are fake. None of them are, tutorial things. These are real life situations. And you can still reason about them in a matter of minutes. You're reading no code, which means now begs the question, like, how quickly do you, read code in, if I would give you the same thing, for example, for the React thing, this would be about 50,000 lines of code or something like that in that specific system. Or so it would take a significant amount of time to do the same thing. So we're not talking about here something that is optional. This is such an obvious competitive advantage that the ones that will do it extensively will just have huge or score huge wins. You know, the first movers here will just have a significant advantage based on this, just like with any other technique that was out there before it. So I'm more interested. I'm not, and also the other thing that it took a while to get an understanding of is that I'm not trying to learn to teach everybody at this point in time. I'm trying to find the people that are already convinced because they've already tried tools. They found that they are expensive, and now we're telling them, look, tools don't have to be expensive. And now, of course, should you necessarily use Glamorous Toolkit for all your work? Oh, no. So if Moldable Development will take off, we will not be talking about Glamorous Toolkit in a decade from now. Or yeah, it will probably still be a relevant thing to talk about sometimes, but that is not the thing. It's like think of testing, right? For the first few years, people were talking about JUnit, right? And then it was XUnit. Who's talking about those kinds of things anymore? Nobody. But we're talking about strategies of when testing is meaningful, when it's not meaningful. We're talking now today about testing in production versus just doing regression testing. So whole new levels of thinking were enabled by the tool, but the conversation evolved well beyond the original tools. The original tools are still meaningful. They're still there, but that's not what the conversation is about. So what I would expect is I would expect very similar things to happen here. First, people will talk about some concrete things like tools. And yeah, we're going to have to do these painful comparisons where people will find some tools. Oh, I found that view somewhere there, which is fine. But what I was showing you is that if I can show you the same thing, the same tool that you learn exactly once, and then you use in many, many different situations, how does that one compare economically to having to learn 1,000 tools, right? So that's the reason why people don't know 1,000 tools, because it doesn't scale like that. So that's
it's striking that you're trying to solving the problem of reading code by replacing it by writing code first.
Isn't it interesting? Yeah.
Because writing is considered expensive. Of course, we talked about it last time, right? That reading is actually more expensive, or at least we spend more time on it. But writing is definitely more risky, etc. You need more. Well, I guess reading is risky as well because you could misread stuff. You're not going to affect the system directly, but the writing you do as a consequence of misreading or misunderstanding something is dangerous. But so yeah. I think for you to push this forward, so the comparison with JUnit, etc., is very apt because you will need to convince people of this by providing tools. A Glamorous Toolkit seems well, maybe there's another way of looking at it where you're not providing the tool, you're not providing specific things, but you're providing classes of things that make it easy to build on. Because now, for example, you show a dependency graph that you used for one problem, but you use it for another problem. But is that what Glamorous Toolkit is? A set of sort of classes of and then yeah, okay, that makes sense.
And it's a classes and it's a language. So this is where it differs. So most of if you look at tools, they typically advertise features. Yeah. We advertise operators. So the environment, the graphical thing. So we can talk about this one if you want to explore this one a bit. But the graphical things, the graphical representations, they are many of them. But the interesting thing is that the way you combine them is you combine them with a meaning, like with this reasonably simple graphical or interactive language. So there are not a lot of, like, you don't have a gazillion features. There are no features. They are just lots and lots of operators, and then you can combine in systematic ways, basically. And then, of course, yes, we do have these classes of, like, we can predict classes of problems people will have. We can't predict specific problems people will have. So we can predict people will have dependencies problems. We just don't know which.
Yeah.
Right. So or like that. Yeah.
But then I think there's a next step that maybe is not present here yet. You showed us some analysis of some React views. Sure, it's a dependency problem, and if you can map the things to, but nobody should have to build React tools except the React creators. So they should build tools that are pluggable into. So you need a marketplace basically.
Yeah. So absolutely. So first of all, right, it's crazy. It's so crazy. Like if you look at React, like how many times this thing is being used? How many times people
but
get into that?
They have tools, right? They have Chrome extensions and things like that, where you can actually do some of the things you.
So that's the crazy thing. That's the worry. That's the problem. When people just see that they are all of these. We reused it at the wrong level, right? Instead of just saying, oh, let's learn a language, like computers used to have a dedicated, like, 50 years ago, you would have computers that were targeted for specific kinds of applications, right? And then somebody came with this idea, oh, let's actually make a generic computer because that's what the theory says we could do. And then it was like crazy. Like, what do you mean generic? I mean, look at this one. You cannot compete with this thing that I hand built specifically just for doing accounting. And it turns out that you can, right? And the same thing is here. We are at a place where everybody's looking for the hand built whole computer that just solves a very narrow set of problems. And then they try to fit their question into that tool. We see this over and over again. And so the tool dominates so much of how people frame problems. That's what I said, that the hardest thing by far to train is to tell people that they can ask any question, and then the tool then will have to adapt to that question.
Yeah.
We're so trained to do the other way around.
I'm still thinking about how you would sort of advocate this, how you would frame it, how you would market it, because if you could, like, we have tools that are extensible through marketplace. We call them IDEs. I think what you're doing is different in the sense that it's a programmable IDE where you don't have a specific API tool, etc., but you can build them using sort of lower level building blocks. So maybe because people buy into things that are the next step of evolution, and maybe you're trying to do 3 steps. So if you can frame it as it's a programmable IDE, that would be
so
bring it closer to what people are used to first.
Yes, so absolutely, this is that's basically what moldable means, right? You want to program it while you work with it, basically extend it while you work with it through programming. But yeah, clearly, right, that kind of conversation, right, or that kind of labeling that has to happen. And we still, so we're at a place. Okay, the first goal with Glamorous Toolkit was, we had this idea a long time ago, and then we said, well, how far does it go? And originally we started from just looking at architecture problems, so legacy systems, and then we started to apply it over and over again, like to many more other things. And then at some point we realized, well, actually this is probably much more generic than we expected to. And then we said, well, how far does it go? And so it's only now that we have a good understanding of what the space is. And yes, we created a little bubble. So we live in a place which is like, it doesn't, it's like a different reality. I have a friend who, second time we met ever, and he said, oh, he introduced me to somebody, says, oh, Tudor, he's living in a different world, and from time to time he comes back and visit us. And it's true, but so this was necessary to do our research, but now, of course, it's a challenge to now say, well, what is it that we did? What do we have here? And this is actually one of the this is the reason why I enjoy having this specific conversation, because you went through an interesting exercise of taking something that was way more, let's say, advanced for its time, and then got into a way in which you transformed it into a conversation that is it's happening everywhere now, right? If you look at domain-driven design, so that process, that's very interesting, and that's the most important thing that I think that's the biggest challenge. So now we've done the content. Let's say we have a very good idea of what the start of the conversation is, and now we are very much interested in saying what is how do we set up the conversation? But the worry is how do we make this conversation? How do we ensure that that conversation is not shallow? So you see, when you have, let's say, 10x, suppose, right? And people are just looking or are happy with 20%, then anybody that will give them the 20%, this is what they will take, because the 10x just looks like too much trouble and they are not interested in this. And the 20% is just not going to solve the problem. The problem that we need to solve is that we need to make the inside of systems way more approachable to normal people, because otherwise the society is not it's not sustainable. That's the problem that we want to fix. So the question is, how do we frame that conversation and optimize it for that goal, not for the little things that we can get along the way?
Yeah, but you could. I'm just sort of thinking, like, the way I'm visualizing it in my head is the gap between the status quo of IDEs and what you're doing, right? And then what would be, if that gap is too big, people won't cross over. If it's too small, of course, then there's no point, and it's a minimal improvement, and they won't cross over either. But if there's like sufficient connection points, and so, for example, take JetBrains, right? Their IDEs, they're all very similar. They're all sort of clearly based on the same underlying framework and code base, and they just sort of compose building blocks and make some custom ones to compose a product, but they sell it not as the universal IDE, but they sell it as Java and a a web IDE and a Python IDE, etc. Which already, and it's even at the point where you could probably, by adding the right plugins, take any of these products and turn them into one of their other products just by using the right building blocks. But I think the framing of it, this is a Python IDE or a Ruby IDE, is very deliberate, because that's how people sort of approach it and how they buy it and how they look for something. Yeah. Right. So you could do something similar and say, this is the Java Glamorous toolkit. It is already pre-programmed or pre-provisioned with the right tools for sort of just Java code editing, plus typical basic tasks, plus the tools to do your own tooling, or the building blocks to do your own tooling, something like that.
Precisely.
I'm not saying that's what you have to do, right? I'm just sort of like finding what's something in between, in the middle of this gap.
Yeah, so definitely that's definitely a direction that we consider. We might not start from a popular language or a language that is already supported by IDEs, but we're considering, so one alternative would be to target domains rather than languages. So because eventually,
but that's
what
again
we're
a step
saying,
further, right? That's
well, yeah, but
people
you sell it to.
Yeah, I get the idea, but you sell it to fintech, and you say this is a fintech IDE instead of this is a Java IDE. Is that what you're saying?
This is one, but just think of something like an IDE for Minecraft.
Yeah.
So something that people already spend the time to do things, or and then target and create an experience that is highly or very specific to a domain that is already recognized. So this is a.
But you could also say it's a React IDE.
Yes, the problem there. One of the things that we noticed, again, like we don't have to be right in this one, because we are definitely not right. We would have 100,000 stars on GitHub if we would be right already, if we would know, if we would have solved the marketing problem. But the one thing that we notice is that if we if you show people an example that is kind of looks like something else, the whole conversation is already lost. Because so it has to be something that is somewhere else. So it's
you
like
can you can see it as a foot in the door thing, right? I don't know if there's a
Yeah.
if there is a Minecraft or a React IDE, but it would be a foot in the door thing, in the same
Right.
sense that JUnit itself didn't create the testing the mindset, but at least it triggered some conversation.
clearly, right. So those are definitely options, and
Yeah. It sounds like, I don't know, right? This is just a hunch I got last time as well. Your vision of moldable development is in a sense holding you back, because you have
Yeah,
this
sure.
big vision and it's holding you back from
Clearly.
marketing a smaller vision.
Yeah,
And then
absolutely.
your risk is maybe that somebody will make a worse version of your ID
Yes,
that's
exactly.
much more marketable,
Yes,
and that will
exactly.
actually not move the mindset forward to your ID.
Precisely. Exactly. That's what I'm saying. Like the most likely thing to happen will be that people will copy some of it, like the shinier part that doesn't make much of a difference, and make that one a success, and that will still not solve the core problem.
Yeah.
That's
But if you're that person, then you still control the conversation to a degree.
Sure. Yes, but yeah, like, like the other thing here to keep in mind is that we created the company to fund the work. So to find the answer, is this one of the things that we see is, I mean, our industry is so dominated by fashion, and some of the things that are fashionable have merit, and some don't. And it's the question here was, how do we ensure that if we do make a fashion out of this, that it has merit? So this is why we went through this like rather elaborate, probably overdoing it, to try to validate it. It's also the bias of coming from more of a research background. So rather than just starting with this idea of MVP, see who's going into it, we literally lived with the consequences of those decisions and see, does it work? So basically pretty much everything we're doing in one way or another, it validates the original idea and sees how far does it go and so on. But yes, right now, so this was the motivation for creating Think. But now we're at a place where we need to outgrow that setup and find ways to propagate the message. And this is where we're actually also interested in help. And yeah, so we're interested in building a community, not necessarily only to use what we do, but also to solve these other complementary problems that we haven't solved. Like, how do you teach this? And how do you teach this in a reproducible fashion and maybe at scale and so on. So, but yeah.
Yeah, interesting problems to have.
Maybe other questions or issues that maybe have arise from somebody else.
Well, right now the mindset still, if you're using this to explore a Ruby code, for example, you would still go back to another editor to change code. Or
Right now, yes, but it can be that in a short while, not necessarily. So Glamorous Toolkit is already a language workbench, which means that we can create editors for all sorts of representations and languages. And this was from the very beginning. And the editors that we have are just an instantiation of it. So, but one of the use cases that we actually look at is, creating documentation for technical systems. So basically combining knowledge management with visualization notebook and targeting the documentation of systems. So this is one of the use cases.
Yeah, makes sense.
Right.
I see that Thomas left because of the storm.
The tree fell. Right.
Yeah, it's very noisy here as well.
So for everybody else, there's a storm happening in Belgium right now. Okay. Are there other questions? So I can take you a brief. I can give you a brief tour on how do we use this one to build Glamorous Toolkit itself and how to use Glamorous Toolkit to learn Glamorous Toolkit. So one of the key, one of the interesting problems here is like in order to scale the learning, then it means that learning has to be scalable as well. So which means that we want to delegate as much as possible to the learner and not put the pressure on the teacher. So, you know, like having tutorials is one way of doing that, but another one would be to empower the people to actually use the environment to learn the environment. So that's actually the first thing that we are telling people to do. So let's take an example. So if I say I'm going to open here I'm going to browse a file, so the current folder, and I can see here this is a file reference. This is an object, and the file reference has different kinds of presentations, right? So I could look at this like this raw thing. I can see path and file system, which is an accurate description of what's happening inside, but it's totally useless. Or I can look at the path here. I can see where in the path it is, or I can look at the contents. And so now here, if I look into something, I can go in there and I'm just navigating through my system, right? So, but the question here is, how is this implemented? How is this view here implemented? So we can think of every one of these views as like a string representation. Like you have, if you have an object and you want to print it to the console, you will, and if you're in some sort of a Java world, for example, you would say I'm just going to write a toString method in the class of the object that I want to print, right? But so first is that because we can display widgets, we don't have to limit the printing just to strings. So we want to print widgets. And the second thing is we don't just want to print one kind of widget. We can print any number of them, which means that I don't know that I shouldn't hard code the name of the method of the class that I will write in the class, but I should just discover it. So an annotation, for example. So which means that these kinds of views here would be defined in methods in the class of the object that we're looking at. So now if I press Option or Alt on this items view, I can see what the implementation is. So this is the implementation here. This one actually opened another object, which is a method definition, which points to this specific method over here that is in this specific class. And of course, I'm in an inspector now, and this object now gives me a source. So which means that now I can go and, you know, I can change things here. So if I can say 2 here, then it changed there. Right, so this is an actual editor of the method that defines this view. And this is what it says. Like it says here, look, it's a column list. It has 1, 2, 3, 4 columns. So 1, 2, 3, 4 columns. And it describes what goes in each of these columns, basically. And that's it. So pretty much all of these views are nothing but transformations. I take some input and I'm displaying some output. And that's it. That's the whole thing. So now this is a method. So the syntax that you see here, this is in this case Smalltalk, so Faro. So this is a class. This is the selector, the name of the method if you want. this is in this case an argument. So this is a method with that accepts a single, that has a formal parameter over here. And this is an annotation. So I have here this GTView is an annotation of this method. So let's actually say, okay, now I want to know how many GTView methods are there in my system right now. So I'm going to open another playground and I'm going to say here, given this name, GTView, I want to find out how many, we call these annotations pragmas in Faro. So we're going to say how many pragmas are there, how many methods are there annotated with GTView. And if I inspect this, I can also take a look at the implementation, and it says here, I'm going to create a class called search pragma filter. And then I'm going to pass this symbol, the string, basically, to it. And so if I execute that code, I get here a search pragma filter. And this is a filter object that knows how to present itself. So how does it present itself? Well, it presents itself like it shows me the list of things. But then when I look at them, right, I can see, okay, this is the abstract file reference. I actually get the editor. So what just happened here? What happens here is that I took a playground, which is normally for working with data, right? We saw it. This was a starting point for doing analysis and static analysis. It was a starting point for doing domain discoveries, was a starting point for doing API, reverse engineering. But it's also the same place where I'm going to say, here's a query over my own source code. And what do I get? I get an object that shows me, I get an inspector over an object that knows how to show me editors. And these are live editors. So what happens here is that, I now have a scoped environment. Right? I just transform my playground and inspector, and now I have a scoped editor, basically, for just for the kinds of methods that I want to look at. So this alone, right, is an interesting thing, and it just shows how far we can go, and just by combining it's how and I know that it is like many people, when they see this one for the first time, they say it's like an uncomfortable, like an unnatural thing. We expect to search for code and to see the code in this very, very concrete place, like in the editor that we know where we have typed the code. But here we just transform this as, well, we built a search tool out of a playground and an inspector. That's it, right? And so now the question here is how many of those there are, right? I can see here that there's a metrics view. And if I click on it, I can see 1,700 plus of these views. And this is in the core distribution. 1,700 plugins, basically, just in the core distribution, right? And then the average lines of code per method is 11 point something. And if I take out the first 2 lines, which is the name of the method and the annotation, I basically am at around 10 lines of code. That's the average cost of a view, 10 lines of code, right? And then you can create these kinds of views as you're going along, right? Like you saw also in the previous session or now. We can create this one in a piecemeal fashion. And this is basically what we, that's how we work. And, you know, like let's see if I think I have here an example. So this is an actual problem that we went through. We wanted to implement a tree map. So we took this paper, and then in the paper, if you look at it, it shows, like, it describes the algorithm and it describes it into a picture, right? So of course, we just, you know, we have the same, basically we're reproducing the same picture in our own thing because it was a debugging tool. And this was the cheapest way to test whether or not we have implemented the algorithm as in the paper, right? Because in the paper you get just a pseudocode. So the cheapest way to test whether or not it's the same was to reproduce the picture. So, and again, like this is a view that literally happens, right? So this is how you would see it. You would see a preview of the result. You will see what steps do I take. Maybe I can take a look at them like this and so on. So these are views that we create out of engineering needs. Like we don't do it for marketing purposes. We create them out of engineering needs. And because we do them out of engineering needs, it means that we can create many different narratives about our systems just by then afterwards composing them. And one of the, it took a long time to learn this one. I just figured this out a few years back, about 3-4 years back, was that we found ourselves sending, we use a chat as a communication tool in our team, and we found ourselves sending many pictures and few words, like the exchange over chat happened through lots of pictures, but few words. And it turns out that these kinds of pictures, they can compress communication. And if I would have to choose what's the most exciting part of it, I think that would be the most exciting part, that they compress, the compression of communication. And I think there's lots of interesting things that happen because we compress communication. Because basically when you compress communications, you're actually increasing the bandwidth of communication, right? Because the bandwidth of communication that can go to you is kind of constant. So if you can cram more things into it, you're essentially expanding it. And that's one of the largest blockers that I see around. And you see lots of scaffolding, for example, that is based on the premise that the communication is fine, like is limited. So there's lots of mechanisms that are put in place just to accommodate with this, but nobody, there's little focus on what happens when you can increase the amount of information that you can get across the table quickly. I suspect that lots of things are not needed anymore from what we today take for as saying that these are absolutely necessary, such as, for example, synchronous meetings. So now another thing that we're now looking at is, so one of the things that is inside Glamorous Toolkit is that it's a knowledge base. So it's a knowledge management tool, which means that here you have a book. You can write a book about Glamorous Toolkit using Glamorous Toolkit. And these are, I think I already showed you a couple of example, like this show that we played a little bit with. But another kinds of thing are something like this. So here we see, this is basically, you have here different snippets. So this is editable. You can have here, in this case, it's Markdown, but the editor of Markdown itself is kind of interesting because it only shows you the Markdown when the cursor goes near it. And you can even embed things into them. It's just to take a peek into what happens there. So this is actually the main reason why we built our own graphical stack, so that we are able to build an editor that does that. So, and by the way, this this thing is actually added by syntax highlighting. So this triangle that appears there is dynamically added as you type, which is a reasonably interesting technical problem. So in here we have this is another kind of snippet, which is a wordly map. So I can go and create these kinds of wordly maps if I want to. I'm going to delete this one here. But here, for example, this node over here actually has a link to another page. So I can have a link like this to software assessment or like that. So if I click on that one, right, I'm going to see this is software assessment. Now notice here how the principle is the same, but I'm now navigating not through code or objects, but through what appears to be just a knowledge base. Let's just like wiki, right? And this is a software assessment. It says, well, look, it has these references there. And I can see how, right, one reference comes from here, but another reference comes from here, right? And even this one, like it updates live. So the interesting thing here is that we kind of have a solution for representing knowledge in a language agnostic way, because these snippets themselves are also moldable. You can program them. And how do you program them? Well, you're going to program them from inside the environment. So you can extend the language that with which you're going to capture knowledge, for example, if you want. And the way you can do it is basically by, if I now go back to I flip here between the editor mode, or not mode, but the interface that is more targeted toward the editing. And I'm just looking at the object behind it. And I can see, oh, look at this. This is a page. And now I'm in an inspector. And so I can, instead of looking at the live view, I'm going to look at just the snippets, like what is this page made of, right? And what kind of incoming links does it have? What kind of outgoing links does it have? So I'm now looking at my knowledge base from a technical perspective. Then, of course, if I can do this, I can also do, little graphs of saying how, those dependency things, right? But those dependency things are about now pages now in my knowledge graph. So I can use it like that. But then, of course, if I can do this, I can also go and say, well, this is an interesting, another kind of example of the difference between tools and operators. So in typical wikis and knowledge management tools today, right, people will advertise this idea of a graph, right? So the dependencies. And this would appear as a feature, like a tool feature. So let's see. Here I have a snippet which actually says there's a variable which is implicit in which is called this snippet. So if I inspect this variable, it actually gives me the object behind this snippet. And then this object knows that it's in a database. So, and I can ask the database for the pages. So if I execute this whole thing over here, I'm going to say, give me all the pages from the current database, right? And then here it is, 153 of them. And these are the pages. And what I want now is I want to see what kind of dependencies are there. So this is a little script here, which does exactly this. It's just a script that says, given these pages, I will create some nodes and I'll create some edges based on all those outgoing links that I could see before, right? And if I visualize that, I can kind of see this. So yeah, I can see, look, there are these connections there. But one of the things that I see here is that, this node here kind of seems to be connected to everything else. So the question here is, what is this node, right? And so that's where your typical notebook kind of starts to, doesn't go further, because what you want is you want to go and interact with the picture, no longer with this one, because I don't know what this is. So, but if I click here on this little node, this is actually just an object, right? So I can just spawn it on the right. And yeah, I can see, look, this is actually the table of contents of the whole book. So of course it's going to be connected to everything because it's a table of contents. Great. So once I know this, that means that I can go and take it out. So I'm going to say, well, instead of having all the pages, I'm going to take all the pages from which we're going to reject those from this book that are titled like this. So if I inspect this, now I have 152 items, right? And now I can go back and then I do the same visualization, but I have a completely different picture, right? So this is where you see how, like, if I just measure the picture here on the right, I'm going to say, yeah, I see a tool that has that, but this is not the same. So this, first of all, is not a feature. It's just a dozen lines of code. That's it. That's the whole thing. And I'm going to use it as when it's going to be useful, but for most of the time, it's not interesting. But when it is interesting, then I want it trimmed to exactly the kinds of things that I want to see, not to what the tool wants to see, right? And then I can, once I have a picture, maybe a map that I kind of, or a graph that I kind of like, then I can also use it as a search tool. So here I extended the same kind of visualization, but in this case, I'm going to highlight some of the pages that maybe are of interest, maybe based on some sort of a query, right? So, and then I can go and navigate, but I can do it in context here. So it's a totally different way of looking at this, but that's kind of how intertwined everything is. It takes a bit of time to get used to it, but once you do it, it's actually one of the feedback that we get from people that are actually playing with this is that they have a hard time, they feel like they are now crippled every time they go out of it. So it's a kind of a, blue pill, red pill type of situation. Especially like presently, right? We should transform it into a much more happy metaphor, but that's how far we went. So again, like this was just a short presentation about how we work, right? So the fact that we have these extensions that are already there, these plugins, we created those out of engineering needs. But those 1,000 extra, or we have more than 2,000 extensions throughout the environment. Those are a small fraction of the whole, all the tools that we have created. And those just happens to be those that we have reused. But we are literally creating a lot of tools on a daily basis to actually drive the way to drive the development of the environment itself. And then, of course, because we've done this, and also the discovery, we wanted to optimize all the process of discovery. So how do we learn about the emergent properties that happen in any environment, including ours? So this is why the focus on queryability and how to find something, and or how to visualize how to find something. And once you know something like this, how then you synthesize maybe lessons for others, which is and what leads to this knowledge management type of thing. So what we have people today doing is they are learning Glamorous Toolkit by doing like a settle casting type of thing. So like every day they're going to say, oh, I'm going to go through Glamorous Toolkit, this is what I've learned, and then start to build a graph of the lessons that they are learning about the environment while working with the environment, and the graph is obviously stored in the environment.
Yeah, it's very impressive. It's, it looks like a lot of fun using it as well. I think that's what you get going for it.
Yes. So the one thing, like how many times we've been into many times into situations where people would say, oh, this is so much fun, and then what we have just showed them was a debugging thing, right? And this is, in fact, that's so exciting, right? Because I mean, we can go to the economic argument, we can talk to the moral argument about how the society is not sustainable, we can talk about the economic argument about productivity increase and so on. But I think ultimately what will probably win, if anything will win, is the fun argument, right? So how can we make working with legacy systems to feel incredibly joyful, right? That it should feel like an exhilarating, like all the time, like people shouldn't want to get high in any other way than just working with a legacy system, for example. So that would be, right, that would be a nice thing to get. Okay, so I would still be very interested to follow up in one way or another, in particular to exercise it through concrete problems. So like Thomas mentioned, one of the things about this, and I'm sure that you're seeing the same thing with domain-driven design, for example, and definitely it was the case with test-driven development. Unless you see how this way of thinking projects into your context, it's just not, it's intellectually, might be intellectually entertaining, but it won't make much of a difference. And that's the challenge. That's also the challenge of scalability. How do you get people to try it in their context? And that's why we're saying, when people are starting to work towards this, is we say, well, we have to start from something that you actually care about. Don't just do abstract. Don't do abstract exercises, because they never work, or we have never seen them working. Basically, take something that is really painful, and once you are seeing it, then you say, wow, it's no longer painful. And this makes such a difference. This is also when we are going into a team and we're coaching a team, we literally start from things that are painful It's because that's what people react to. Say, wow, look at that. It was painful and now it's no longer painful. Or ideally, it was painful and now it's joyful. That kind of transition. So seeing it work in something that you are seeing as context, this would be a very interesting experience to go through. So help you go through, or just hear of you go through any of it. Okay, well, thank you very much for your time.
Thank you
And
for all the explanation. It's very interesting.
Yeah, thank you for the presentation.
Yeah, thank you.
Thank you very much.